New edition of the Heat Treat podcast. Today, we're going to talk about cleaning technologies. We got from all the way from Germany, very close to Stuttgart. I didn't get the town. Sorry, Andreas. Andreas Fritz from Hemo Cleaning Technologies. How's it going over there, Andreas? Great to meet you, by the way.
Hi, Carlos. Great to meet you. And thanks so much for being your guest today. We're doing fine over here. Summertime. Just waiting to get finished to go into my pool afterwards. Yeah.
Fantastic. I'm glad you took the time because I believe it's late afternoon for you. Today, right now it's early morning for me. But it's great to have international guests from all over the world speaking about technologies that are involved with heat treatment. And today we're going to talk about cleaning washing, cleaning methods, the technologies, what it is, the most common mistakes. Andreas is an expert on the subject. And when it comes to washing, we all know that all the attention on heat treat actually goes to the machines that are actually doing, microstructure transformation, that we're having the heat, the gases, the transformation inside the chamber. But cleaning is also a very important part of the process that might not be the main, but it's a process itself, right? So Andreas today is going to explain us, what is important, why do we not take in consideration, and some of the new technologies that he has seen through his experience. He's managing director of Hemo, a company that is devoted to supply cleaning technologies all around the world. But why don't you give us an explanation about the company you work for, a little background of your industry? That'll be fantastic, Andreas.
Yes, the company Hemo, we merged in 3 years ago. It was the company Emo, which is really well known in the heat treatment business. And we merged together with the company Hösel. That's the reason why we now have this H in front of Emo. So now it's Hemo. And Hösel was coming more from the fine cleaning side. And together we now have a good size to be able to deliver and also to service all our machines all over the world. We have a turnover of roughly $35 million. We have 140 people working for us only here in our 2 locations in the south of Germany. And in addition, we have subsidiaries which are situated in France, in India, in China, in Mexico since 2 weeks now, in Querétaro.
Oh, I gotta know the guy. You gotta introduce to me.
Yeah, that's it. Yeah. And as well, this year we opened up a sales company in Texas, in the US, the Surface Alliance Cleaning Technology Corporation. Yeah, so this is what we are doing. We try to give the people more knowledge all over the world how to clean parts before assembly, before heat treatment, before coating. This is our business and nothing else. And we have a 40 years experience in this case. We have always been the technology leader in this case. We developed all the main technologies and also patented it. So that it's really true that we are the inventor of this stuff. And I'm really happy to talk to your audience a little bit about this issue today, because it's a really big issue.
So it's a pretty decent sized company and very international company with what you explained. I'm just curious. So Emo, it sells washer itself, or cleaning technologies might be a process as well. So what's like the main core of the company?
The main core is building the machines here in-house, or in license in other countries. And we build the machines, we make the service of the machines. And for the customer, we try to invent new technologies to assume him to have really, really good clean parts. We do not do any commercial cleaning or shop cleaning or stuff like that. It's only machine building.
Machine building, fantastic. So, Andreas, can you give us a basic explanation 101 on the cleaning processes industry-wise related to heat treatment, of course, and some of the most common methods and applications that you see?
Well, basically, there are 2 options you can do. One is water-based cleaning. This is what many people know about. You clean with water. You have a detergent inside there. Afterwards, you do a drying process with vacuum or atmospheric only by blowing. This is the one hand you can do. What we mainly focus on is the cleaning with solvents like hydrocarbons or modified alcohols. This means that all our machines are totally under vacuum. Yeah, the whole thing is under vacuum, so you can increase the flash point, which means that you're working with the temperature of the liquid above the flash point. And this ensures, especially in the heat treatment, this ensures that the polar residues you have, like oil, grease, fat, and stuff like that, are really going to be removed very well. And you have perfect dry parts afterwards because all is done in vacuum and with high temperatures.
Now, you mentioned the most common, which is water-based cleaning. Some of those use solvents, some of them do not use solvents, and higher or lower temperatures. What's important, not running a vacuum. I mean, if you're not running a vacuum and you're doing just water-based cleaning, what you're gonna get if you actually compare it to a vacuum clean machine technology?
I always give an example, which you usually know from home. When you clean the pan in the water and it was oily, and afterwards you clean a glass of wine, or when you had wine, and you take out the glass, you see that the whole glass is still full of oil. And this is the main trouble you're going to have in water cleaning. Yeah, water is something anorganic. This means water can really good clean salt and some other stuff. Yeah, but it's really bad in the behavior of cleaning like oils or stuff like that. Yeah, because it just not mix it up with it. That's the reason why we invented in 1995 the hydrocarbon cleaning technology under vacuum. And since then, all the heat treatment companies finally found out that cleaning after oil quenching can be done without having really bad quality after a number of batches. Yeah, because the more oil you bring inside your water bath, yeah, the less good is the quality. You have the white spots on the parts and things like that, which you still have after the tempering process. And really important is to see that when you clean with solvent, there is no need to refill the solvent. There is no need to change it. Yeah, it's always good quality due to distillation, and also the quality of your clean parts is really good. You don't take over the oil which is left on the parts into the tempering furnace. This is why we specially focused with our solvent machines to go into the heat treatment business, because the trouble was really big in this industry.
There was not like a machine that was able to clean new parts and oily parts, because we get two processes. Some people, not most of them, some people do a pre-wash and a post-wash, right? Yeah. But all of the people has to do a post-wash, right? Depending on the cleanliness of the parts you're getting, right? So when you have a machine and you're doing the pre-wash, you're getting cleaner parts because you're not running that oil. I mean, you just want to get out and clean the remains of the last process, so your atmosphere furnace doesn't have oil remains, or the process goes cleaner. But after you quench a load on oil or another quenching medium, let's say polymer or salt, you name it, then you have to dry, to clean it out before going on the temper. So you got a pre and a post wash. That's how the American industry actually get it.
Yeah,
what's the recommendation to do pre and post wash on two different machines?
Yes, this is the recommendation, and the reason is quite simple. The post-washing, in case of post-washing, we usually talk about the post-washing after oil quenching, and removing the oil is very simple. You need just a solvent cleaning machine with one tank and the good distillation and the vacuum drying, and then all the problems usually are gone. Yeah. For the post-cleaning, you have more than oil on the parts usually, because you never know where it's coming from turning, milling, or whatever. You have water-based coolant, you have oil and grease and stuff like that. That's the reason why we invented roughly 20 years ago our so-called hybrid cleaning machines. And these hybrid cleaning machines are able to clean with solvent or with water or with both in the same machine. So this means we start with solvent, we remove all the organic stuff, and in order not to get any white spots on it, we continue with a water step in addition. And this water step takes away all the salt residues, fingerprints, and all the other inorganic stuff which is on the part, to make them perfectly clean before the heat treatment or before coating and so on. That's the reason why you really need to check what you need to do for pre-cleaning. Post-cleaning is quite simple, in my opinion.
It's quite simple, but now, before we started recording the podcast, you actually say something that caught my attention, is that some of the companies that you work with, some of your customers, actually they remove the cleaning process from the heat treatment facility and they go somewhere else, right? Did I get you right? But that will make material handling and trespassing from one load to another basket. It's more time, logistics, and time consuming. But is this a common practice in Europe? And if so, there's a cost implication on the material handling, delivering, basketing. What do you think about that?
Basically, our machines have the same size like the furnace.
Okay.
So you can always have the same batch size into the furnace and into the cleaning machine. You put the cleaning machine into the same line so that it can communicate with the loading system and so on. Usually it's like that. You have your furnaces and you have two cleaning machines. One is the pre-cleaning machine and one is the post-cleaning machine. All are communicating together. No need to take hand on the parts or whatever. Everything is also done in the main computer. We have a communication processor which is communicating with the furnace and so on. So everything can be really done in automatic mode in order to save the costs for labor. That's true, because it's a big deal, yeah.
It is a big deal. Now, when it comes to furnaces, maintenance is also a very big part of the expense. What are the key points to maintain a washer, a vacuum washer, which is mechanically complex and advanced and has electronics and computers? What are the key points to not to lose the quality on a cleaning process on one of these washers? And how often do you have to have that maintenance?
I mean, to keep the quality of the cleaning agent or the solvent which is inside is very simple, because it's all done by sensors and you can all read on the screen what you need to do. You have a distillation process, you have water evaporation. You only need to refill your solvent and some cleaning agent and water sometimes. Never really change it in total. This is not necessary. So this also saves a lot of money for disposal of your media. Yeah. And the other things you need to do, usually the heat treatment companies do an annual maintenance, like they also do with their furnace. Yeah, so you need 4 to 5 days. There is a guy coming from our side to doing the maintenance just to check if everything is all right. And in the meantime, the only thing you need to do is check if the vacuum pump is okay, sometimes do an oil change, check the filters which are inside, maybe remove them when they are full of dirt or particles or whatever. So very simple in operation. That's the reason why the people really love our machines, when they have automatic lines where you don't want to enter all the time.
Now, I would like to go a little deeper on why to use a vacuum washer instead of a standard washer with no vacuum, just water-based cleaning. We all know that washers that are not on a vacuum, right? They're simple machines, just mechanically in and out immersion. They might have an oil skimmer, and you get the parts relatively clean, right?
Yeah.
Most of the time we have oil drips. We're separating oil. The water is heated out by an electrical component or maybe a burner. But if you go and make the next level of investment for a vacuum water-based cleaning machine, right? What are you gonna get as an advantage? What does vacuum makes it such a big advantage? What is the science for using a vacuum or not? And when the economies of scale does pays to invest on a higher technology machine than just standard washer? Because when we're dealing with automotive work and aerospace work, I do understand that if you have to reprocess stuff and if you're dripping a lot of oil, you're gonna get a bunch of money loss, maybe even on time. But when you're doing a simple application, right, maybe fasteners or something, will that be worth looking at having a vacuum washer? Just help me understand a little more deeper. What do we have to have a vacuum on a washer, and the economies of scale on investing on a higher level machine that just a standard mechanical washer?
I mean, a vacuum washer, the way we build it, even if it's only a simple one-tank solvent machine, it can never be as cheap as a dip and spray washer. Yeah, this is just totally simple, because you see the way it is built. And so on. But on the other hand, as you say, the economy of scale is also concerning the quality of the parts. Yeah, how often do you have to put them into the waste barrel after the heat treatment because the quality is not good? Yeah, and how often do you need to change your water? How much detergent do you need when you refill with new water and things like that? All the operation costs. This is something you also need to focus on. And this is the one point, and the other point usually is just the cleaning quality as itself. Because we do not spray, we make like a flood injection washing in there. We can use ultrasonic, to have mechanical something on the part as well. We can swivel the parts, of course, when you have deep boreholes, and by the fact that it's under vacuum and with high temperature. You never have a problem with blind holes, for example, and you never have a problem with the drying of the parts when they are coming out, because you bring so much energy into the parts with the high temperature, and you have such a good drying result afterwards that you can just take the parts when they are coming out, because and you can make a final assembly or pack it and send it to the final customer without any quality check, I would say. This is usually in the European heat treatment where our machines are placed. This is something which is standard, that you just don't check the parts, because usually they are clean after the cleaning process.
So you're based in Europe, but you say you have companies of subsidiaries, licenses, or offices all around the world. We all know that Europe it's the place where we have more automated lines, because it's mostly for automotive work. What are the world trends or tendencies that you see regarding washers? Europe buys the most vacuum washers. There's some in America. How Asia clean things different from yourself? Mexico, I don't know. But what are the trends worldwide that you see? How each location wash their parts?
Well, earlier it was like 100% water-based cleaning. Yeah, nobody ever thought about cleaning with solvents. Yeah, because they are flammable. Some old ones were hazardous and things like that. Things now have changed because the solvents, they are quite harmless now, which we are using. They are available all over the world. And with the right technology, it's also very simple to run the machines. You don't need any special education. You can use the same guy operating a water-based simple spraying machine as well as our vacuum-based cleaning machines. This is not a big deal anymore. This, like it was in the past, and in Europe, you see that the quality which is necessary is mainly done by the automotive industry and also by the aircraft industry. This is the reason why we supply a lot of machines in this case to the large heat treatment groups, like Alberts, like Bodycoat, and so on, and also to big companies which are automotive suppliers like Schaeffler, Canlibers, Continental, and so on, because they really need to release themselves on the quality of these kind of machines. And wherever they go in the world, usually they just make a copy of their European locations. They copy them, they go to Southeast Asia, they go to Mexico, they go to the US, and they just make a copy factory over there. And together with these customers, we are able to enter these kind of markets and also to get new customers around them, which are subcontractors, suppliers, and so on. And this is the way the solvent cleaning business is spreading all over the world. It's mainly not done by us, it's mainly really done by our customers, which are satisfied.
Now, when we have, let's talk about the cycle on the process and the process variables that go into place. So you actually quench a load after carburizing or carbonitriding, you name it, you quench it, right? And then the transfer car or takes the load and puts it on a washing machine. What's the cycle, the mechanical cycle, and the process variable like time? I don't know if you have a solvent chemistry of injection, or I don't know, like turbulence that goes on in the machine. So the load goes into the chamber, the door closes. What happens next? We got a vacuum. We heat up the ambient. Can you explain us the process that goes inside a washer?
Yeah, it goes automatically with the loading car into the machine. We close the door. We evacuate the cleaning chamber to 80 to 100 millibar roughly. So we are down in the vacuum business now. And the first thing we do is now make a flood washing. This means out of the tanks with high pressure pumps, we put the solvent into the cleaning chamber, like we call it. We make some circulation flood washing. After that, we take out the solvent. Then we make a vapor degreasing, which is really important. First, to get a better cleanliness result, and second, to bring the drying energy by a high temperature into the parts. And afterwards, we make the vacuum drying, and we go down, as I said, below 10 millibar, perfectly to 0 millibar to the absolute vacuum in order to have 100% dry parts. And after that, we ventilate the cleaning chamber to atmosphere. We open the door and the parts are cleaned. A usual cycle like this with 1 tank solvent is about 15 minutes for a 1 cubic meter batch, like 1200, 900, 900 mm. This is the regular thing.
That's a pretty complex process explained really fast. I mean, you just mentioned it really fast, but if we actually compare it to a standard washer, it just goes in, the door closes, there's no vacuum, and there's just an elevator that sprays or dumps the stuff and goes out, right? It's also 15 minutes. But what you explained, we have vacuum, we have solvents going in, we have pumps with pressure, then we have to do a drying on a vacuum. So there's a bunch of automatic processes that have to be on the very spot, right? Just to get the parts clean. So what are the most common mistakes that you see when doing this process that customers run that can be easily solved with a very simple twitch?
Yeah, mainly the big problems usually are that the customers bring a lot of oil into these water-based dip cleaners, and afterwards they go to the tempering furnace, and after the tempering they are wondering why they have so many white spots on the parts, and why all the walls are very oily and dirty in the tempering furnace after 1 year. So they need to spend $10,000s of US dollar per tempering furnace, yeah, to remove the wall and to clean it and so on. This just cannot happen with a solvent machine. This is very simple. It's also very important when we discuss about costs of our machines compared to costs of simple cleaning machines or dip washers, because when you talk about the total costs, the maintenance costs, you almost don't have any in our case, because everything is automatic, everything is done to be able to have 1 year before the next maintenance is going to start. So this is the one thing. Yeah, people are wondering why the parts are so clean when they come out of our machines, and why they do not have any problem with spots and so on, with weakness of the hardening and so on afterwards.
Now let's talk about the racking, because it's also very important. If you get parts racked on a cast alloy tray, it's very different than if you get parts just all spread on a basket.
Yeah.
Does racking plays an important role on the washing? I assume yes, but I would like to hear it from the expert, right? Because there's some commercial heat treaters that they just have standard basket and they can just throw the parts in, right? No accommodation it's needed, right? But when you're doing gears or pinions or some of the transmissions, we actually have a cast alloy fixture on a, very well spread, very engineered. Does that, has anything to do with the cleanliness on the part on a water-based cleaning or a solvent cleaning technology way?
I mean, when you have the wrong geometry, I would say it really has caused maybe some problems in the past for the water-based systems. Because you have like deep boreholes which are looking to the top. Yeah, you fill it with water while you do the spraying and dipping and so on, and afterwards you're just not able to remove this water again out of the deep borehole of the blind holes. Yeah, this is something you also don't have with the solvent machines, because we have this mechanical movement, this swiveling up to 15 degrees on each side. So this means you can really take out a little bit of the liquid, and the rest of the liquid is being taken out by the vacuum drying process afterwards. And the machine is really drying as long as there is nothing inside. There is a sensor in the cleaning chamber which really says the drying process is not finished before you have usually it's 50 milligram per cubic meter of air inside of the cleaning chamber. And this really physically confirms that the parts are dry. So you can take them directly automatically into a tempering furnace without any problem. Yeah. And on the other side, this also means for the solvent machines, you really don't have any big deal if it's a alloy rack or if it's a CFC rack or if it's a basket which is made of metal, how the parts are stacked on it, we just don't care in this case. I think it's a big trouble being caused on the water-based side, but not with vacuum machines.
Now, when you are designing alloy fixtures or to load the capacity of parts on a furnace that is going to go to a quench tank, the limitations are the weight of the part, because the motors have so much horsepower in order to move those. You know, the geometry of the part, you know, if they need to be stacked on a specific way, not to touch each other, and the surface of the part, right? I have some customers that they go very low weight, and the geometry is relatively simple. You know, fine blanking or fasteners or injectors, maybe stabilizer bars, right? Or parts that are hollow, right? That they have a bunch of surface, and their loads are relatively, relatively light, right? It's not a heavy load, but it's a very optimized load because of the geometry on the surface. What are the factors to consider in order to place a load on a clean machine? If we get a bunch of surface, let's say like injectors, hollow materials, the solvent is going to go out and wash the part the same as in the hollow part as in the other surface body, or maybe some of the fasteners, if it is the case, or fine blanking. Because when we get, I believe in carburizing or heat treatment, they call it hot spots, when parts are touching each other and you do not get the quenching media. How does it work inside a washer?
Yeah, I mean, inside the washer, you don't have these hotspots because with the vacuum we have inside, you always reach any place. This is not a big deal.
But what I mean, if their parts are touching each other, right?
Yeah, they are touching each other. Yeah, this is no problem. Yeah, you can really clean them when they touch each other, because the liquid is still going inside this very, very little gap. Yeah, it's gonna pull through. Yeah, it's like soaking. Yeah, because it's done under vacuum. Yeah, this is really simple in this case. Yeah, this is only possible with vacuum. When you have atmosphere, it's just not possible to do it. Yeah.
Okay, and what about oil separation? There's still some oil in the parts, right? But how do you take the oil out from the parts so you can recycle it and put it back to the tank?
When we clean the parts, this means when we fill the solvent into the cleaning chamber and we clean the parts, we take out of it and then we take it over into like an evaporator. So we make a first evaporation over there. The very clean, like vapor is going back into the tank. So the tank is really clean. And we have a concentration of 50-60% of oil to solvent, which is being pumped over to like an external distillation unit, like we call it. It means external from the process, but it's still internal of the machine, of course. And there we make an up concentration again by distillation, by evaporation, to 80-90% of oil and a final residue of 10-20% of solvent. And from this place, it's going to be removed and pumped out of the machine into like a metal old waste barrel. Then you can just dispose it. Yeah, that's very easy in this case. All the oil you bring in must be taken out. Yeah, this is for sure.
Yeah, for sure. Okay, fantastic. So I believe we have covered most of the basic regarding cleaning technology. I did learn a lot. That's why I do the podcast as well. cleaning technologies, right? It's a great process to know besides standard cleaning. Is there something that you think we missed that it will be worth sharing with the audience?
Yeah, as I mentioned, maybe on beforehand a little bit, we really have a very good experience with solvent washers, with vacuum solvent washers. But sometimes, especially in case of the pre-cleaning, it's not enough. Yeah, this is the reason why we invented all the mixtures. We have these hybrid cleaning machines, as I said, which are very popular for pre-cleaning, where you just use the solvent to remove most of the oil, and then you can keep on going with the water. And the water will last really long because it almost has no contamination, because most of the contamination has already been removed on beforehand with the solvent. This is also a very special difference between a water-based solvent and a hybrid cleaning in this case. And of course, this is really a long cycle time. Yeah, we talk about 3 times longer than a usual solvent cycle time. And pretty new now also for heat treatment shops. We have it now since 2 years on the market. It's our so-called Beyond system. This means you have water part and the solvent part, and you mix the water and the solvent and the detergent together. And so you don't have a separation like in the hybrid cleaning. This means you don't separate solvent and water. You mix them up together. You clean the part, and physically it will be separated again by physics. Yeah, so you have the water with the density of 1, which is below, and you have the density of like 0.8 for the solvent, which is on top, and we separate it. Yeah, and with this new technology, we made it possible to have a much faster pre-cleaning than we had on beforehand. So for any kind of applications, we have something for the customers. This is really important for me to tell them that it's not only solvent washing.
And thanks a lot for your time, Andreas. It's been a great podcast to have with you. Actually, we learned about all these washing, solvent, and cleaning technologies. You know, this is what we're trying to do on the podcast: bring new technologies, new products, new processes from experts all around the world to the new generation of engineers, right? So, Andreas, just to finish the podcast, you're a relatively young guy. You have a lot of knowledge. You are actually an expert of the subject. You actually manage a very good sized company internationally wise. But if for the new guys that are entering the industry, there's the saying that most of the guys with experience are retiring, and we're not recruiting enough young engineers to fill that experience that they're retiring. What will be a personal advice or experience that you would like to share for the guys that are just taking this new job on a heat treat shop, or they just want to become a part of a mechanical engineer on an OEM on this industry, which is the heat treat industry?
Yeah, the first thing for young people mainly is to tell them that they should never be scared of making a mistake, and always try to look what kind of technologies which are on the market. Maybe also try something new, and not being scared that they lose their job when they make a mistake. Yeah, and very often it's good to talk to specialists, also like our company is, in order to find out what is really necessary. Yeah, we always want to make sure that the customer only does what is necessary and not what is recommended or wished by the designers, like I say. Yeah, because designers, they always want to have the best. Yeah, and then they tell the young people to always want the best, but the best is very often not necessary, costs a lot of money. So I always recommend also to my very young people, which come after university, to use their own brain and not only doing what other people tell them to do.
Fantastic advice. Thank you so much for having that. Andreas, we'd like to thank you again for being on the podcast and sharing with us your experience, the technology, what your company does. Thank you so much. Let's hope this is not the last time we speak. And I hope to see you in one of the shows whenever they come back, right? And actually meet you in person. It was Andreas Fritz, Managing Director of Hemo, a company based in Germany for cleaning technologies. I would like to remind the audience that we're uploading weekly podcasts. We're on YouTube, LinkedIn, Spotify. You don't want to have the video capability. And we'll see you the next week with another specialist on the Heat Treat podcast.